Hi everyone, and welcome back to CODEMAS. Today, let's briefly talk about bit operators in C Sharp. In real life, we are used to deal with numbers in decimal system. The base is 10, and using digits from 0 to 9, we can represent any number. We are using powers of number 10 because 10 is a base. And these are our digits. In computers, binary system is being used. That means that using digits 0 and 1, we can represent any number. And we want to use powers of number 2 in this case, since 2 is a base. These are digits in binary representation of our decimal number, 324. Digits 0 and 1 are bits, and 0 represents that something else is false, and 1 represents that something is true. Binary operations on two integers work bit by bit, processing matching bits together. On 2 bits, we can apply bitwise AND, which is 1 if both b1 and b2 are 1. We have bitwise OR. It's 1 if at least one of bits b1 and b2 is 1. We have exclusive OR. It's 1 if bits b1 and b2 are different. If one is 1 and another one is 0. We have bitwise negation. It's applied only to one bit, and it's used to switch 0 to 1 and 1 to 0. When dealing with binary representations of number, we have shift operations, shift left and shift right. Here we are shifting bits of n for 2 places to the left. And here we are shifting bits of n for 3 places to the right. Let's now solve one LeetCode task, which will give us a chance to apply our knowledge immediately. Task 1486. Exclusive OR operation in an array. So we are given an integer n and integer start. If array nums is defined like following, nums of I is start plus 2 times I, where I is in range from 0 to length of nums, we need to return the bitwise exclusive OR of all elements of nums array. Let's start with a well-known approach on this channel with pseudocode. First, let's create the nums array. Now, when we have a nums array, let's calculate the result. This is the sign for exclusive or bitwise XOR. We calculated the result, have it prepared, and in this line we are just returning it. Notice that we initialize result to 0. Let's briefly explain why that works. So in for loop, we had an XOR operator. If we had, for example, plus here, we would initialize result to 0 as well. But if we have here the multiply sign, we will initialize the result to 1. We actually want to initialize the result to neutral for operation we have. Let's look at a brief example to see why x exclusive or 0 is x. For example, if x is, for example, this 0 represented with the same number of bits is this, and the result x exclusive or 0 is following. We are applying the operation bit by bit. So we have bit 1 and 0. 1 XOR 0 is 1 because bits 1 and 0 are different. Next, we have bit 0 here and 0 here as well. Those bits are the same, so we have 0. Here we have 1 and 0. It is 1. 0 and 0 gives 0 in XOR. 0 as well. And the last one is 1. So this is the same as the original value. 0 has no impact to XOR operation. Also, since we need only one element at a time, there is no need to use array and save n elements in memory. We can just calculate the value of the current element when we need it. So our pseudocode can be transformed to the following. So here we don't have a whole array anymore. We just have one value in each iteration, and it's enough to calculate the result. Also, this expression can be written in the shorter form like this. Now, let's transform this pseudocode into C#. Our result is integer. We need to return an int. And here we're just returning the result. Let's now run and submit our code to check our solution. Okay, excellent. Let's discuss the time and space complexity of this solution. Time complexity is linear since we have n iterations, so it's big O of n. But space complexity is constant. We have just this variable and this variable, two variables in total. But for the previous solution with the whole array, we would have big O of n, linear space complexity. For those who are not familiar with the complexity, no worries, it will be briefly explained in the following videos inside the CODEMAS serial. In this video, we cover different topics on algorithms, data structures, and complexity. Some of them have already been discussed in this serial, and the rest of them will be covered in the near future. That's it for today's lesson on bit operators. I hope this video helped clarify bit manipulation in coding. Keep practicing and see you tomorrow with another topic.